Welcome to Josh and Emily's Guide to Pharmacology. Today, we will be talking about a drug class called monoclonal antibodies. Antibodies that are all produced by the same B-cell clone are known as monoclonal antibodies. Monoclonal antibodies all have the same specificity for antigen and bind to target cells to tag them for destruction. mAbs can also bind to cytokines or their receptors to neutralize their pro-inflammatory activity. Advantages of mAbs over low molecular weight include high specificity and long half-life, enabling precise action and infrequent dosing of the drug. There are 4 types of monoclonal antibodies, shown in the table here, from entirely mouse amino acids to entirely human. Monoclonal antibodies work by a number of mechanisms. Ligand blockade occurs when antibodies bind to a ligand, preventing the interaction with its receptor. Infliximab and adalimumab bind to soluble and receptor-bound TNF-alpha. They are used in the treatment of Crohn's disease and rheumatoid arthritis. Omalizumab binds free IgE, preventing IgE-induced mast cell degranulation in severe allergic asthma. Monoclonal antibodies can also cause receptor blockade by binding to the receptor, thus preventing its activation by the ligand. Tocilizumab binds to the IL-6 receptor, obstructing its interaction with IL-6, slowing the progression of rheumatoid arthritis. Trastuzumab is used for HER2 positive breast cancer and has multiple actions. It binds human epidermal growth factor 2, HER2, resulting in receptor down-regulation, halting proliferation of breast cancer cells. Furthermore, monoclonal antibodies can cause depletion of antigen-bearing cells by 3 mechanisms. Antibody-dependent cellular cytotoxicity, ADCC, is when a natural killer cell recognizes the heavy chain constant region of the monoclonal via its Fc gamma receptor, leading to lysis of the target cell by the natural killer cell. Similarly, antibody-dependent cellular phagocytosis involves recognition of the antibody and subsequent phagocytosis of the target cell. Complement-dependent cytotoxicity involves complement protein recognition of the antibody and subsequent cell lysis through formation of a membrane attack complex. Rituximab works by this mechanism and is used in cancer and autoimmune disease therapy as it depletes B cells. Side effects may occur when parts of the monoclonal antibody are recognized as foreign. This can activate innate and immune reactions, causing the release of cytokines. If enough cytokines are released, this may be termed a cytokine storm. Cytokine storms are characterized by hypotension and may cause lung injury and renal failure. They are potentially fatal since they can progress to cardiovascular shock and acute respiratory distress syndrome. This effect has been observed for rituximab. Adverse effects may also be due to on-target effects of the monoclonal antibody. This is evident for trastuzumab. Activation of HER2 promotes proliferation via an anti-apoptotic signaling pathway. The binding of trastuzumab to HER2 inhibits anti-apoptotic signaling and promotes caspase activity through pro-apoptotic signaling. This results in apoptosis, which is the aim in breast cancer treatment. However, the presence of HER2 on cardiomyocytes results in the destruction of cardiac muscle cells, impairing contractility and ventricular function. Fortunately, this is rare. Other side effects include infections, platelet and thrombotic disorders, autoimmune diseases, cancer, and dermatitis. Antibodies are not metabolized by CYP450 enzymes, but they can influence the hepatic clearance of small molecule drugs by an indirect mechanism. Pro-inflammatory cytokines such as IL-6 suppress CYP450 enzyme expression and activity, reducing the metabolism of small molecule drugs. Tocilizumab can increase CYP450 expression under conditions of inflammation, such as during rheumatoid arthritis, by inhibiting the action of IL-6. This results in increased metabolism of small molecule drugs, reducing their half-life. This indirect interaction is an important consideration in rheumatoid arthritis, where monoclonal antibodies are often used in combination with other drugs such as methotrexate. So this was a brief overview of monoclonal antibodies. Thank you for watching, and we hope you learnt something.